Hey, it's Dave here. In my previous video where I automated my mailbox, I featured this little scaled down mailbox with a flag that goes up whenever I receive post. In this video, I'm going to show you exactly how I built it, how to assemble it, and how to get it working in ESPHome and Home Assistant. Before we get started, this video is a direct follow-up to my previous mailbox automation video. So if you haven't watched that one yet, I'd recommend watching it first, as we'll be using the same sensors, input booleans, and automations we created in that video. I'll leave a link in description. I also had some really interesting suggestions in the comments of that video. Quite a few people recommended using LoRa for mailboxes that are further away, which is definitely something I'd like to experiment with in a future project. Someone else also shared a really clever solution where they used a counter helper with a single contact sensor. The first time the mailbox opens, it shows the mail has been delivered, and the second time it knows the mail has been collected. Then they use that to trigger announcements and lights around the house. I thought that was a really clever way of doing it, and I always enjoy seeing the different ways people solve the problems, so keep those ideas coming. For this project though, we're going to take the mailbox automation we've already built and add this miniature mailbox display where the flag moves up automatically and plays a sound when you receive post. For the build, we're going to need a D1 Mini, a DF Player Mini, a Servo, a speaker, a micro SD card, and access to a 3D printer. You can either build the electronics using a prototype PCB or use the carrier PCB I designed, which I'll show later in the video. I'll put a complete list of everything you need in the description. One important thing to prepare is the SD card. The sound I'm using is the classic You've Got Mail sound, saved as 001.mp3 in the root of the micro SD card. I'll provide that sound file along with other project files. I'd also like to thank PCBWay for sponsoring this video. If you like to use the same carrier PCB for your own build, I've made the design available for the PCBWay shared project section, and I'll leave a link in the description below. Alongside PCB manufacturing and assembly, PCBWay also offer 3D printing and CNC services, making it possible to manufacture everything from custom circuit boards to mechanical parts and prototypes. Thanks again to PCBWay for supporting the channel. So the first thing we need to do is set the D1 Mini in ESPHome and get the code on the board. Let's jump into Home Assistant and get started. From here, we're going to select ESPHome Builder, click New Device, click Continue, New Device Setup, and I'm just going to give this device a name, click Next, and then uncheck Use Recommended Settings and select ESP8266, and if I just scroll down, I'm going to look for Wemo D1, R2 and Mini. It doesn't massively matter what you choose here because we're actually going to overwrite some of this code anyway, which actually does reference the board. But I'm going to set it like that and click Next. And now we can click Skip. And this is the new device we've just added. So I'm going to click Edit. And what we're going to do is copy this code and we're going to overwrite it with some of the example code I've prepared earlier, which will be shared. So I'm just going to transition to a split screen where you can see both of these codes on each side. On the left, we've got the initial device setup code, and on the right, I've got the code that I'm going to be using. So I'm just going to overwrite some of those values very quickly. So device name, I'm just going to change. Same for friendly name. API encryption key, which is this one here. over-the-air password, access point SSID, and the same with the access point password. Now, I'm assuming you have already used ESPHome before, and if that's the case, then your Wi-Fi SSID and password will be using secrets. If that's not the case, then the first time you flash your board, you'll be asked to sort of put in your Wi-Fi details. Otherwise, you may need to make this your Wi-Fi code. Now that we've updated all of these substitutions, I'm just going to copy this code on the right. And I'm going to overwrite everything here. So it should look something like this. If I just give you a very quick summary on the code, this is the only part that you'll need to change, which we've just done. This section here is the pinouts. As long as you follow my wiring diagram and use the same hardware, you shouldn't need to change anything below. So we've got the DF player TX pin is connecting to D6 on the D1 Mini, and then you've got the DF player RX pin connecting to D7 on the D1 Mini. The servo, which is the mailbox flag, connects to D1, and then I've also made a mailbox reset pin, which is a tactile switch. So when you press that, it resets the state to assume you've collected your post, and that's using D5. All the below is basically just substitutions. And if I go a little bit further down, there's various buttons that I've also made along with numeric values. This particular section here is for the servo, where you can specify the incrementation in steps. So it goes from -100 to 100. I've also added a section here for audio repeats, because what's going to happen is when you receive post, it's going to play an MP3 sound, and you've got the option of, you might just want it to say the announcement once or multiple times. I've set the initial value to 2, because what I find of notifications is you kind of half hear it and you need to be told again to acknowledge it. So I like it to say the notification twice, but you can change that to just 1. And then you've got all these other platform templates for the flag going up. You've got another one for the flag going down. I'll describe it better when we go into device settings. You've got this section here for the volume. It's going to have the initial value of 30, and I would leave it as that because the particular speaker I'm using isn't actually that loud. So 30 is perfect, but you can change it if you want to. And then there's a few buttons I've created. One which will play the MP3 sound, which is the You've Got Mail. You've got a button to move the flag up, a button to move the flag down. And then it's also going to create a switch. And when that switch goes up, it will then cause the flag to go up. And when the switch is off, the flag is going to go down. Now we're going to save those changes. Click Install. And because this is the first time I'm flashing it, I've got it plugged into my computer via USB. So we will select the second option, plug into this computer. This can take a considerable amount of time. It can take up to 5 minutes. So probably grab yourself a coffee, pause the video and come back once it's finished this stage. It's basically having to compile all the code into a bin file, which is why it takes a considerable amount of time. Once that's finished compiling, you're going to select Download Project. And I'm just going to save it into an appropriate location. Then we're going to select Open ESPHome Web. Click Connect. And I'm just going to plug in the USB cable. So I can see it is COM port 5. Then select Connect. And we're not going to choose Prepare for First Time Use because we've already compiled the code. So we're going to select this option, which is Install, and then browse to the path where I downloaded that bin file. then click Open and click Install. Now installation is complete, we can click the X to click away, and we can just close that tab and close all those windows down. If we now go into Settings, Devices and Services, and you should now see your new device here, which is looking promising. I'm going to click Add and then click Submit. And then click Finish. It's optional to choose an area, and I'm just going to choose Skip and Finish. And it will present you with all these controls. I'm not going to go into too much detail about this because it'd be much easier for me to explain once we've got the PCB assembled and the 3D printed parts put together. The only thing you need to make note of at the moment is this switch here, which is Mailbox Presence, because we're going to create an automation shortly. And if you go into Settings, just make note of that entity ID. I'm just going to quickly come out of this setting and just show you how I got to here. So you go to Settings, Devices and Services, do a search for ESPHome, and then do another search for Mailbox, which is this one here, and it takes you to that page. Now that we've flashed the board, we need to create an automation that will allow our miniature mailbox display to integrate and stay in sync with the existing mailbox automation we created in the previous video. So let's get that set up. Back into Home Assistant, if you go to Settings, Automations and Scenes, select Create Automation, Create New Automation, and if you click on these three dots here and select Edit in YAML, I'm just going to paste in this example code which will be shared. From this code, you've got 4 triggers. The first trigger is when the input boolean mailbox 4 goes from off to on. It's going to set the trigger ID to 1. Then you've got the second trigger, which is when input boolean mailbox 4 goes from on to off. It will set the trigger ID to 2. The third trigger is when your mailbox notification present switch goes from off to on. That will set the trigger ID to 3. And the fourth trigger is when your mailbox notification present switch goes from on to off. It will set the trigger ID to 4. If I just scroll down, below that we have 4 different actions depending on which of our 4 trigger IDs activated the automation. So if trigger ID 1 is being activated, then it's going to set your mailbox notification mail present switch to on, and then trigger ID 2 is obviously going to do the reverse. It will turn it off. And if I just scroll down a bit further, the final 2, trigger ID 3, the input boolean mailbox 4 is going to be set to on, and the final one will turn it off. So essentially, it's just syncing the mailbox notification switch with your input boolean mailbox 4. Now, you will need to update these entity IDs. The mailbox notification present switch, you should have identified that earlier in the video, but just as a very quick reminder, from ESPHome, it's going to be this section here where it's got mailbox presence. Click on Settings, and that is the value you're going to need to copy. And to get the input boolean mailbox 4, if you copied my code from my previous video, there is a good chance it's already got exactly the same name. But just as a quick reminder on where to find it, if I just go to this tab, go to Settings, Devices and Services, click on Entities, and if you do a search for mailbox 4, you should have this result here. And when I click on that, then go to Settings, that's the entity ID, and in my case it's already that value, so I don't need to change it. I'm just going to quickly update the values on this automation so all the entity IDs are true entity IDs, which has now been set. And just before I save that, if I click on these three dots and select Edit in Visual Editor, just to explain this a little bit easier, you can see here are the 4 triggers where Mailbox 4 changes from off to on, when Mailbox 4 goes from on to off, when Mailbox Notification Demo, Mail Presence changes from off to on, and you've got the last one, which is the reverse. And if I go down, here you've got the 4 different triggers. Trigger ID 1 is switch.turn-on, which is a Mailbox Presence. Trigger ID 2 is exactly the same, but it's switch.turn-off, which again is Mailbox Presence. And then option 3 and 4 is referring to the Mailbox 4. So option 3 turns it on. And if you go to option 4, it's going to turn it off. Now we're going to save that automation. And now the input boolean and the switches will sync perfectly. Now we're going to move on to assembling the components onto the PCB. I'm going to be using a custom carrier PCB for this project, but there are a few different ways you can put everything together, including using a prototype PCB. So let's take a look at the different options. This is the empty PCB. On the top left, the D1 Mini is going to be positioned here. And then on the top right, you've got the DF player module. On the top, you've got some extra expansion pins. Then below that, you've got the 1K resistor. Here, you're going to need a 3-pin mail header, which is for the servo to connect to. And then the screw terminal is going to go here for the speakers to connect to. And then here, you'll be soldering the tactile switch. If you end up soldering all the components directly to the PCB, it's going to look like this. Now for the speaker, it's connected to the screw terminal and just placed loose here. You can also solder the D1 Mini and the DF player module via a female header pin and have the rest of the components directly assembled. And again, the speaker is going to be loose like this. The final option, which takes a little bit more effort and admittedly looks a bit messier, is to build everything on a prototype PCB. I designed my carrier PCB around the same dimensions and component positions, so whichever option you choose, it will still fit inside the enclosure. Something important to note is the position of the tactile switch. It needs to be in a specific location on the PCB so it lines up correctly with the 3D printed button in the enclosure, or include wiring diagrams showing exactly where it needs to go. Next, we've got the 3D printed parts. Before you start printing, I just want to quickly jump into my slicer and show you the correct orientation for each part. These are the parts you're going to be printing, and none of them need build support. Now ignore this particular section in red and black, that's just because I'm multicolor printing. Now you're not going to be printing all of these parts at once. The reason I put them all on the bed at the same time is just to illustrate the orientation they're going to be printed. Starting from this item first. So just make sure it's printed in that particular direction. Then you've got the lid, and the lid essentially snaps onto the mailbox body. And you've got this pole here, and you'll notice that that bit is longer than that part. And that's because one end is going to basically go into here and connect to there, and the other end will go through this lid. Just make sure when you print this particular pole part that you print it in this orientation, and you also print it quite slowly, because I have had a few failed prints when doing this. Then you've got the lid for the base, and this is part of the tactile switch for the button. So you've got that little pole, it's just going to feed through here, and that button cap is going to connect to that pole. This is going to be the base, which the lid is going to snap onto. And for here, the last part is the mailbox flag. I've chose to print it in red. It's up to you. You could have it the same color, but it just looks a bit nice. And because I'm using a servo to make the flag move, I'm also using the screws supplied with the servo. And the screws are a little bit too long. So what I've done here is I've just made this little washer that you'll use later on to make the screw a tiny bit further away. This will make sense once I've printed all the components and I'll show you the assembly. And just to remind you, none of these parts need build support. Now that we've got the parts printed, it's time to put everything together. So let's take a look at how it all assembles. We're going to start off by connecting the servo to the mailbox body. This bit might be quite tricky to film because it's a little bit fiddly, and you want to make sure that these wires are hanging outwards, and this little part where the actual flag's going to connect to is going to be coming out of this hole. So if I just hold it from here, and you might want your finger around this part, try to sort of push it outwards. Again, this is quite a tricky bit to film, so let's see how this goes. And then you're going to use the built-in flag that came with the servo, and you're going to try to connect this together. This is probably the hardest part of the assembly because it's just a little bit fiddly. Okay, that seems to have worked. Now we are going to connect the mailbox flag. And what you'll notice is I've got this screw here, but I've also got this little washer that I've made. So you're going to put that screw through. That's going to go through here. And if I just quickly grab the screwdriver, you're going to connect this next to that flag and then just screw it on. Now we've got the actual flag secure. There is a chance you may need to remove it later because when you power this on, the servo only moves 180 degrees and you may find that you've connected it and it's already at one end. So you then have to take it off and put it back on again. But hopefully I've got this right. Now for this actual wire, this needs to go inside and it needs to come out of there. So I'm just going to do that as well. So that's now coming out. And then you've got the lid, which should just snap in. It's just going to go through these holes. That's probably the most difficult part of the assembly done. The next part is you're going to feed this wire through this pole, and it needs to be the slightly longer end is going to go through here. So now you've got it looking something like this. The next part is we're going to get your PCB and we're going to connect it to this base. In this example, I'm using a PCB where everything is soldered directly on. You may not be able to see from this footage, but just on the corners, there's a little bit of a riser that allows these PCBs to be slightly elevated. So I'm just going to place that this way through. And it should look like that. So you've got the USB-C connection and the SD card connection is available. One downside is this is quite fiddly to remove if you need to. So to try and make it a bit easier, I've added this little tongue. So what you can do is as I press this down, it just sort of pops it up and allows it a little bit easier to release. Just before we connect this lid, what we're going to do now is grab this, and this needs to go through that hole. And then you'll see that should connect like that. And now we're going to just connect the servo plug, which is going to need to go to those 3 pins. And just make sure that hole, which is this hole here, needs to be aligned with the tactile switch. So if I just push it on here, it should look something like that. And then the final part is you've just got this little button, the body for the button. So that will just join together. And it's just going to go through that hole. And what I'd find now is as I push down, you may or may not be able to hear it, but it's actually knocking the tactile switch each time I press that button. And the purpose of that button is it's a reset button. So when you get mail, that flag is going to go up, and then you can either press that and it'll make the flag go down, or you can have another automation to reset your mailbox status. Now that everything is assembled, there are a few different controls in Home Assistant that I want to quickly run through, and we also need to calibrate the up and down position of the mailbox flag. So let's jump back into Home Assistant and get that set up. If we go into Settings, Devices and Services, and do a search for ESPHome, then do a search for Mailbox, and it's this one here, Mailbox Notification Demo. From the control sections, starting from the top, you've got audio repeats. What this means is when you've got post in your letterbox, it's going to play the audio file twice. I personally like it to say the notification twice because you may not have been concentrating when it first spoke. I'm going to bump this down to 1 because it just makes the demonstration I'll be showing later on a bit quicker. Flag position down and flag position up. That's part of a calibration step, because when you press these buttons here, move flag down and move flag up, it's going to move up and down, but it's not going to know the exact position. So what you'll need to do, and if I just overlay the actual mailbox sensor, I'm now going to press the flag position down. Okay, so minus 47 seems to be about right, and I'm just going to do the same for position up. So that looks about good, and now if I press these two buttons, I can just confirm it's working properly. So if I press move flag down, you can see the flag goes down, and if I press move flag up, you can see the flag goes up. So I'm just going to put it back down again. This mail presence is a switch, and what happens is when that goes on, it's going to automatically move the flag up, and it's going to play a sound effect. So if I just press that now,
you've got mail.
You can hear that classic "you've got mail," and I'm just going to press it again to turn it off, and you'll see the flag automatically goes down. There's also a manual button here where you can just press it,
You've got mail.
and you can hear that sound effect. This slider bar here is just a manual override where you can just change the servo flag to a setting. Doesn't really serve much purpose other than just testing, so you can see where the actual numbers which relate to the position. And the volume, it defaults to 30, but just leave it as it is because the speaker I'm using is actually fairly quiet. So you're better off just leaving it at 30. Reset mailbox status is to do with the manual button we've got, so that when you press that tactile button on the actual miniature mailbox, it changes the reset mailbox status briefly to on. And when that toggles, it's going to automatically undo this mailbox presence setting. But otherwise, that is all set up and ready to go. Now that everything is assembled and configured, we're going to wrap this up by testing the finished project. We'll make sure the flag goes up when the mailbox flap is opened and goes back down when post is collected, and test the manual reset button. Now I'm just going to test opening up the mailbox flap.
You've got mail.
And you can see the flag has gone up. Now I'm going to open up the mailbox door, and you can see the flag goes down. I'm just going to repeat it one more time.
You've got mail.
and then open up the door again. And I'm just going to open up the flap the last time, and I'm going to test the reset switch.
You've got mail.
Which you can see works. It makes the flag go back down. And there we have it. We've now got our miniature mailbox display up and running, so when post arrives, the flag goes up and plays a sound to let us know when mail is waiting to be collected. If you've built something similar, or you've got a different way you would have approached this project, I'd love to hear your ideas in the comments. There's some really interesting suggestions in my previous video, and it's always useful to see different ways people approach the same problem. So I look forward to reading your comments. Thanks for watching, and I'll see you in the next one. Bye for now.